Hello students, welcome back to my channel once again. Today in this video, I am going to teach you a very important topic, that is work done by an ideal gas in reversible adiabatic expansion. In the last class, we have learned work done by an ideal gas or by a perfect gas in reversible isothermal expansion. Hope you have studied and practiced that answer also. Fine. And also students, one more thing to keep in your minds. This question can be asked in another way, like see, I have written here, show that PV power gamma is equal to constant in adiabatic process, and also TV to the power gamma minus 1 is equal to constant. Okay, so you have to be very careful when you get the question paper. There might not be this question, explain work done by a perfect gas in an adiabatic reversible expansion. There might be how do you show that PV power gamma is equal to constant in adiabatic process? Then the same answer you are supposed to write. Okay, so shall we start? Now, in the beginning, in the first classes of thermodynamics, I told you about the types of thermodynamic processes in which we have come across adiabatic process. What is meant by adiabatic process? It is the process where there is no transfer of heat between system and surroundings and vice versa. That means the value of Q is 0. So kindly take your notebook, put the side heading like this, and to start with, here you write down, students, in an adiabatic process. I am writing for the sake of you. In an adiabatic process, comma, there is no transfer of heat. There is no transfer of heat between system and surroundings. Between system and surroundings, and vice versa, surroundings and system. Okay, so as there is no transfer of heat between system and surroundings or surroundings and system, Q value will be equal to 0. Write down, hence Q is equal to 0. Okay, students? Below write down from first law of thermodynamics. This also we completed, students. From first law of thermodynamics, what did we learn from first law of thermodynamics? Here write down, we know that Q is equal to dE plus W. Okay? Have we not learned this, students? Do you remember? From first law of thermodynamics, we know that the expression for Q is equal to dE plus W. Okay? Now, from this expression, we can write Q is equal to dE plus PdV. Why? Because W value is PdV. W is equal to PdV. Put it in brackets so that it will be easy for you to understand. Now, we know that Q is equal to 0 in an adiabatic process. So, I am writing in the place of Q as 0. So, dE plus PdV, from which we get that dE is equal to minus PdV. Okay, so dE will be equal to 0 minus PdV, which is nothing but minus PdV, students. Okay, so mark this as equation number 1. Understood? Next, below write down, we also know that CV is equal to, what is meant by CV, students? Heat capacity at constant volume. We have seen that CV is equal to dE by dt. Rate of change of internal energy with temperature is heat capacity at constant volume. Okay, so from this expression, dE value will be equal to cross multiplication CV into dt. Written? So, write along with me. Fine. So, here we have seen CV is equal to dE by dt. That is, dE is equal to CV into dt. Written, students? Now, substituting the value of dE in equation 1. Okay. Equation 1, what do we have? dE is equal to minus PdV. But dE is equal to CV into dt. So, substitute CV into dt in the place of dE. Okay. I am writing here CV into dt is equal to minus PdV. Just write down like this, students. Minus PdV is equal to CV into dt. Okay. So, now give this an equation number 2. Fine. Clear? I just have brought this to left side, brought this to right side. That's it. I did not do any great derivation or great mathematics. Fine. Now, below this one, you please write down ideal gas equation. Below this write down ma. Ideal gas equation. Ideal gas equation for 1 mole of a gas. How much it is? For 1 mole of a gas is, now you should tell me, what is ideal gas equation for 1 mole of a gas? Very good. PV equals to RT. PV equals to RT. Okay. Now, from this PV equals to RT, P value will be equals to RT by V. Okay. P value will be equal to RT by V. Is it clear, ma? Have you written, students? P is equal to RT by V. Now, what to do this with P is equal to RT by V? We will substitute this P value in equation 2 where there is a P. Okay, will you do that? So, write down. I will wait for you. Written? Okay, I am writing. Please check whether you have written correct or not. Equation 2 minus RT into dV by V is equal to CV into dt. Okay. So, P value is RT by V, right? So, I have substituted value of P in equation 2 minus RT into dV by V is equal to CV into dt. Completed, ma? Now, look here. We know the relationship between Cp and Cv. What is Cp minus Cv? It's equal to R. Okay. So, I will write in the place of R as Cp minus Cv. Okay. So, before that, what I will do is, look here, ma. Here it is dV by V. Right side there is dt. Left side there is t. So, I will move this t to right side so that same variables will be on the same side. Minus R into dV by V is equal to Cv into dt by t. Okay. Same variables on the same side. Now we will write in the place of R as minus Cp minus Cv into dV by V is equal to Cv into dt by t. Okay. In the brackets mention since Cp minus Cv is equal to R. Clear? Shall we proceed to the next step? Okay. So, what I do is, right side there is CV. Okay, we'll bring this CV to left side. Where will it go? It will go to the denominator. So here write down minus CP minus CV by CV into dV by V is equal to, now there is no CV here, so dt by T. Okay, we will try to solve this. Minus CP by CV minus CV by CV into dV by V is equal to dt by T. Okay, so we know that CP minus CV is equal to R, and there is also one value for CP by CV, which is nothing but gamma minus CV by CV 1 into dV by V is equal to dt by T, brackets mention, since CP by CV value is equal to gamma. Okay students, written till there? Understood? Let us try to open the brackets. So minus minus gamma, minus into minus plus 1, put it in brackets, into dV by V is equal to dt by T. Okay, so till here clear minus gamma plus 1. So next step what I do is, plus is there before 1, minus is there before gamma. So I will just reverse it. 1 minus gamma I will write. Is there any wrong in that? No, right? Okay, so we will write the next step. So next step, 1 minus gamma into dV by V is equal to dt by T. Mark this as equation number 3. Till here, hope everything is clear. Fine. Now, let's proceed. Next, below write down students, integrating the above equation. Above equation means equation 3. Above equation within the limits V1 and V2 on left hand side and T1 and T2 on right hand side. Okay, limits on left hand side V1 and V2, limits on right hand side T1 and T2. Okay, so there is a difference between integration and differentiation students. Differentiation means a small change, integration means the complete change. Okay, so now look at equation 3. So we are integrating left side within the limits V1 and V2, right side within the limits T1 and T2. So how to write, I will show you here. 1 minus gamma integral dV by V within the limits V1, V2 is equal to integral dt by T within the limits T1 and T2. Okay. So the solution of integral dV by V is, students, next step I am writing 1 minus gamma into ln. What is ln? It is a natural logarithm. Okay, that is log of base e is called as ln, which is nothing but natural logarithm. So ln V from V1 to V2, it is equal to same integral dt by dt ln t from T1 to T2. Okay, this can be written as 1 minus gamma into ln V2 minus ln V1 is equal to ln T2 minus ln T1. Okay, so now I am not writing within the limits. So now the solution of this is ln V2 minus ln V1 is equal to ln T2 minus ln T1. Fine, ma? Now, next step will be 1 minus gamma into ln V2 minus ln V1 is written as ln V2 by V1 is equal to ln T2 by T1. Fine. Now, next step, ln V2 by V1. Are you able to see, ma? ln V2 by V1. Now, this 1 minus gamma goes as a power term. 1 minus gamma is equal to ln T2 by T1. Okay. So, left side there is ln, right side there is ln. So, we can cancel both sides logarithm. So, what remains, ma? So, I am writing here V2 by V1 to the power 1 minus gamma is equal to T2 by T1. Okay. In the power expression, we have 1 minus gamma. So, this 1 minus gamma, I will write it as gamma minus 1. So, to change it as gamma minus 1, this also has to be changed. So, V1 by V2 to the power gamma minus 1 is equal to T2 by T1. Okay. So, I changed the power as from 1 minus gamma to gamma minus 1. So, as we like, we cannot change. So, when we are changing it as gamma minus 1, this also has to be changed. So, it has to be changed as V1 by V2. Okay. So, now carefully mark this as equation number 4. Below write down, students. We know that, here write down, ma. We know that P1 V1 by T1 is equal to P2 V2 by T2. This you have studied in your intermediate. P1 V1 by T1 is equal to P2 V2 by T2. So, from this expression, P1 V1 by T1 equals to P2 V2 by T2. Look here, students, if you do the cross multiplication, we get P1 V1 into T2 is equal to P2 V2 into T1, right? Cross multiplication, P1 V1 T2, P2 V2 T1. Okay. Now, from this one, T2 by T1 you write, T2 by T1 is equal to, so P1 V1 goes to the denominator and P2 V2 goes to the numerator. Okay. So, now we have T2 by T1 value as P2, this is V2 ma, not X. Okay, P2 V2 by P1 V1. So, this value we will substitute in equation 4 where there is T2 by T1. Will you do that? Right. So, next step would be write down V1 by V2 to the power gamma minus 1 is equal to P2 V2 by P1 V1. Okay. So, here also we will do cross multiplication. V1 into P1 V1, or look here ma, P1 V1 into V1 to the power gamma minus 1 is equal to P2 V2 into V2 to the power gamma minus 1. I am writing here. Look carefully. P1 V1 into V1 to the power gamma minus 1 is equal to P2 V2 into V2 to the power gamma minus 1. Okay, so here there is a V1. Here nothing is written. What's the meaning? To the power 1. V1 to the power 1 into V1 to the power gamma minus 1 is equal to V1 to the power 1 plus gamma minus 1. So what happens? Plus 1 minus 1 gets cancelled. So right side also the same. P2 V2 into V2 to the power gamma minus 1. So V2 to the power 1, V2 to the power gamma minus 1. So V2 to the power 1 plus gamma minus 1. 1 and minus 1 both gets cancelled. So what remains? P1 V1 to the power gamma is equal to P2 V2 to the power gamma. Okay. Next step, write down students. So look here students. Next step is P1 V1 to the power gamma is equal to P2 V2 to the power gamma. So in general we write it as PV to the power gamma is equal to constant. So this is how we show PV power gamma is equal to constant in an adiabatic process. Understood? Okay. So now one more is there. What is that? TV to the power gamma minus 1 is equal to constant. Suppose you are asked the question, show TV to the power gamma minus 1 is equal to constant in an adiabatic process. So what are you supposed to do? You should write till equation 4. Okay. So you should write the derivation till equation 4 till here, and after that you can directly do the cross multiplication. T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. Okay. So then we will get automatically TV to the power gamma minus 1 is equal to constant. Okay. So I will write here. Next, here I will write, suppose if you are asked, show TV to the power gamma minus 1 is equal to constant. Okay. So you have to start the derivation from the beginning, and then you should stop near equation 4. So I am writing here, taking equation 4. Taking equation 4. What is equation 4? V1 by V2 to the power gamma minus 1 is equal to T2 by T1. Okay. So here you do cross multiplication students. T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. So this can be written as TV to the power gamma minus 1 is equal to constant. Therefore, TV to the power gamma minus 1 is equal to constant. Put it in a box. Fine. So this is all about work done by a perfect gas in reversible adiabatic expansion, or this can also be asked as show PV power gamma is equal to constant, and one more question, show TV power gamma minus 1 is equal to constant. Okay students, so learn carefully, practice carefully, twice or thrice, then it would be easy for you. Okay, so we will meet in the next video with another topic. So please don't forget, if you are watching for the first time, any of you, like, share and subscribe. Those who have already subscribed, please don't forget to share with your friends. Okay, so take care, stay safe and stay home. Bye bye.